Hi guys, today I want to talk about this function, and this is an idea of where it's saying the velocity is equal to this function of time, this quadratic expression of time. So as time progresses, the velocity changes for this particular object. Now if I was to draw a velocity time graph, I probably could do with finding the roots. So if I said minus t squared plus 8t minus 7 equals 0, then I think I'd probably times through by -1. So I would get t minus 1, t minus 7. So t equals 1 or 7. So from 1 to 7. Now I can see it's a negative quadratic and it will be fairly symmetrical, so I think it's going to come like that. Now, from a velocity time graph, what you should know from GCSE is that area underneath represents the distance travelled. And I'll call that the letter S. So, in thinking about this, say I wanted to know how far is the travelled how far does it travel between 2 and 5 seconds. I'd be looking at finding that area. So I'm looking at evaluating this area between these two values, and that's suddenly quite hard because this is a curve. And when we did it at GCSE, we looked at things like triangles, rectangles and trapezia, but when you've got a curve, finding the area is trickier. But we've got this new tool of integration, and integration helps us to find the area under a curve. As one of its many uses. So if I was to integrate my function, minus t squared plus 8t minus 7 dt, and I can come between the 2 and the 5, and that was really one of the big clues here. Between the 2 and the 5, that would give me minus t cubed over 3 plus 4t squared minus 7t between 2 and 5. So putting that into my separate brackets, I'm going to have minus 125 over 3 plus 4 times 25 minus 7 times 5. Take away minus 8 over 3 plus 4 times 4 minus 7 times 2. So looking at this, I've got minus 125 over 3. This is 100, take away 35, so that's 65. And then take away minus 8 over 3. Then I've got 16 take away 14 is 2. So I've got to do 65 take away 2, which is 63. And then minus 125 over 3 minus 8 over 3 would be minus 117 over 3, which I think comes to 63 take away 39, which is 24. And we have to go back to think about units. Velocity is likely to be in meters per second. Time is likely to be in time, so I think I'm looking at meters. So the idea really is applying this that we've done before. So integrating between the two limits actually will give us the area underneath the curve if we have represented what we're doing as a graph. But it's one particular use of integration, but it's probably the most common use of integration. So please take it on board.